when we are working with units and quantities, sometimes rather than diving right into the math, we kind of want to have an idea of, okay, well, we have this quantity and I think it's about this, right? And so oftentimes you're maybe in a grocery store, you have a recipe and it says you need 1 pound of potatoes. Well, okay, you don't want to buy the 5 pound bag of potatoes because, well, that's 5 pounds. How are you going to use the other 4 pounds? So then you're in the grocery store thinking like, okay, well, how much is a pound? Like, okay, and then so you're kind of having this idea in the back of your brain, like, okay, I have this idea about what a pound is, but now if you were to think about that in terms of kilograms, your perspective might shift a little bit. So, because we're not used to working with a metric system, and so it's important to think about what units of weight or mass might look like. So when we're thinking about a pound, that's actually mathematically it's 2.2 pounds is 1 kilogram. But so that is to say there's about a half kilo in 1 pound. And so just to give you a rough comparison of what the weights might be. So when you're holding a pound of hamburger, pound of chicken, pound of whatever, that's about a half of a kilogram. Okay. And then when we're thinking about pennies and like just how much a penny weighs, that would be maybe 2.5 grams. And then inevitably at some point, a doctor's going to ask us to step on a scale, and then we have to, not look at the number because we're maybe overweight, and then we feel bad, and then we have to go on a diet. Well, when we're thinking about weights, just for comparison, you may weigh somewhere around 160 if you're a guy. Girls probably a little bit less on average, but 160 pounds is about 72-ish kilograms. Okay, just to give you a rough idea. So divide by 2 in a little bit for pounds. Okay, then when we're thinking about units of distance, okay, we know that a meter is roughly a yard, so we maybe have that comparison in our brain. But then when we think about maybe an inch, right? An inch, you may know from previous studies that an inch is about 2.5 centimeters. Okay, and coincidentally, an inch is the diameter of a dime. So 2.5 centimeters is in a dime's diameter. And then just to give you a comparison more visually of a centimeter, and then as you grow along, and then certainly, so myself, I'm about 6 foot on a bad day, and on a good day I'm 6'2", and you know that your spinal cord compresses over the course of the day. So when you wake up in the morning, you're actually your tallest that you'll ever be during the day. And so if on a bad day I say I'm 6 feet, that's 1.8 meters. Okay, so each of these, so the first row is kind of units of mass, the second row is units of length, and then this third row is going to be units of volume. So you might, if you are familiar with kind of syringes, they're typically gradated in milliliters, and so one nice conversion, and I will ask you to remember this, is that 1 cc is 1 cubic centimeter, and that is also 1 milliliter. Okay, so that actually provides a nice way for us to convert between liters, that measure, or that unit of volume, and meters, which if you remember, meters cubed was a unit of volume. So it allows us a nice way to convert between these two. Okay, and then when we're thinking about a liter, okay, that, and actually for example, when I was in Spain, we often had to fill up the vehicle, and this was for a vacation, but we had to fill up the vehicle, and it was dispensing gasoline in terms of liters. And so just to give you an idea of how much a liter is about the same as a quart. And so you might remember there's 4 quarts in a gallon, or maybe you don't. I always have to ask something about how many liters, quarts, etc. are in something. So but a liter is about the same as a quart, okay, roughly. And then when we're thinking about blood in the body, so if you think about a gallon of milk, there's about 1.5 gallons-ish of blood in the body, but that equates to approximately 5 liters, and there's a range because of, very natural variation. Okay, and then in terms of volume, if you think about water, we typically measure water in terms of cubic meters, and so if you're looking at your water bill, you might see this on there. Okay, so that's just some ideas here, and then now we're going to zoom out. So these are all like everyday objects. Now just to put things in a bit of a larger scale for us. Okay, and I'll just put these all up here. So if we're looking at distance from the Earth to the Sun, also known as one atomical unit, is like 10 to the 11th meters. Okay, height of Mount Everest, 1 kilometer. Okay, and then here we go. Thickness of a hair, less than 1 millimeter. Okay, and then when we look at diameter of atoms, okay, very, very small. Okay, and again, just comparison of units. So when we talk about all the water in the oceans and the seas of the world, a lot of liters, like 10 to the 23rd. Okay, liters. And so if you can imagine, that's a 1 followed by 23 zeros. Okay, write that out, and then over the course of the video you may finish writing it out. Blood in the body, okay, we talked about that. Bacteria cell, not a lot of volume in there. And then carbon atom, holy moly, 10 to the minus 27. So that would be 1, or sorry, it would be a 0 point and then 26 zeros, followed by a 1. Okay, so very, very tiny, okay, in terms of the amount of stuff packed into a carbon atom. And then in terms of mass, Earth's atmosphere, kind of that mass of all the stuff that we might pack in there. Ocean liner, so you might imagine like a cruise ship or something, 10 to the 12th grams. Grain of table salt, really tiny, okay? And again, water atom. And then the last thing here is just with temperature. So there exist conversions between these, and we will see these later in the course. So I'm not going to spend too much time on this, but just a comparison of, for example, when water boils, 373 Kelvin, 100 Celsius, 212 Fahrenheit. And then also at when water freezes, okay? So kind of different scales here. The Celsius is really just a shift from the Kelvin, but then Fahrenheit, yeah, you can see that there's this conversion. To get Fahrenheit, you need to do some math and multiply by 9/5 and add 32. Okay, so that's the idea. So this little video here is just meant to illustrate when or what we need to keep in mind when we're thinking of these different quantities and the size of these different quantities as well as the numbers. So whenever you're approaching these, like it's always whenever you're approaching a math or a problem related to units, it's always good to think, okay, well, does my answer make sense? And that's where this qualitative perspective might come in and inform. So if you're saying that, you know, the mass of a pencil is 10 to the 12th grams, I think you better check your answer, because it's not 10 to the 12th grams. That's more like on the order of the ocean liner. Okay, so something to bear in mind as we proceed through our study of the metric system.